We have a problem. Our civilization is built on the fleeting foundation of cheap and abundant energy. Without huge amounts of very cheap energy, we would be unable to maintain our society, our economy, or our food production. The energy humans used until just a few centuries ago was embodied in the food we ate and natural resources we used for clothing and shelter. We didn't have a separate supply of energy to power different tasks. But that changed in the 1700s, when we learned how to convert the energy in coal into power to be used for many different processes. Energy suddenly became progressively cheaper from when coal began to be used widely. Oil was a huge step beyond even coal in energy density, transportability, and flexibility of use. Oil became the superfuel. By the 1960s, oil was even cheaper and more flexible and had come into universal use. However, by the 1980s and 1990s, energy began to become more expensive as the richest and most productive oil fields began to reach the end of their best years. Now in 2016, humans are scouring the planet for energy and are exploiting increasingly marginal sources. The oil sands and fracked oil both require a great deal of machinery and energy to extract the end product, which used to gush so willingly from Middle Eastern and Texas oil fields. To illustrate the decline in productivity of the world's energy sources, consider the measurement called Energy Return on Energy Investment, or EROI for short. This measurement relates the energy input required to generate an energy output, resulting in the usable net energy, the energy that has actually become available to use in society. In the early days of the richest fields in the Middle East and West Texas, 1 barrel of oil would produce enough energy to find, drill for, and pump 100 barrels of oil for an EROI of 100 to 1 and an energy output of 99. Today, it takes much more energy to mine sticky sand and melt the oil out of them than it does to put a pipe into a large pool of oil and stand back as it gushes out of the ground, as it did in the earliest days of oil exploitation. And of course, when we use more energy to produce less energy, GHG emissions inevitably rise. In 2016, the EROI of the Alberta oil sands and tight oil has declined to approximately 5 to 1. Fracked oil and deep water oil also share an EROI of around 5 to 1. The worldwide EROI of oil is currently around 17 to 1 and falling. Biofuels are possibly not even energy positive with EROIs at Canadian latitudes of between 0.7 to 1 and 1.4 to 1. Eventually, all of our energy will be renewable because the non-renewables, fossil fuels, will have been mined to the point where more energy will be required to extract what remains than the output provides. The EROI of wind generators is currently as high as 14 to 1. Solar PV arrays have a current EROI between 4 to 1 and 8 to 1. Human society will have to adapt to a much more expensive and less abundant energy going forward. Pursuing our current growth forever path would result in massive and repeated shocks to our economy and society. We need to both reduce our energy and resource consumption, stabilize our population, and transition to renewable energy much more quickly. Genuine progress is impossible without metrics which accurately represent the problem, making it critical that we stop measuring energy production through the fog of dollars and start measuring it in real terms of EROI and net energy. It's time for a change. Let's work towards a sustainable society, Canada. www.sustainablesociety.com